My name's Alistair Noyce. I'm a Parkinson's UK doctoral research fellow at the UCL Institute of Neurology. I'm also a trainee in neurology on the London training scheme, and my particular interest is in patients with Parkinson's disease and other movement disorders. My research is in the early identification, or if you like, risk stratification of people for future Parkinson's disease, with a view to, if we can make progress in that area, this is a group of people we could intervene on in the future and try and delay or even prevent Parkinson's disease in the future. What motivates me to do my job is that I've worked in the area of neurology for the last 4 or 5 years, and particularly with patients with Parkinson's disease. Mm-hmm. I've been fortunate to be at the National Hospital for Neurology and Neurosurgery over the last 4 years and spend a lot of time with the same patients, seeing them regularly and seeing how things change with time. I'm aware that there are lots of different types of patients, but yet our treatments for them are always the same. And actually, we need to make better progress on that front. We need to define subgroups of Parkinson's disease better and tailor treatment for those specific groups of people to try and help them as individuals or smaller groups of patients. Why is Parkinson's UK a good organisation to work with? Well, I think that their finger is very much on the pulse of both what the research community wants to do, but moreover what the patient community wants to do and desires. They work very closely with their researchers. They assess their research in a close way and make sure that the research findings are communicated back to the research community and the patient population. They also go to patients and ask them what are their priorities for research, then find the people that will do that type of research for patients so that the research that's done meets the patient's needs. It really feels that there's a multidisciplinary, multinational assault on Parkinson's disease at the moment. There are so many groups striving to find people in the earlier stages of disease, biomarkers, and effective treatments to use with those people that makes me feel that if there's so much momentum at the moment, then a breakthrough's got to be on the horizon. What would I like people to take away from my talk? I'd like people to wake up to the fact that Parkinson's disease is really becoming a public health problem. The rates are increasing at quite an extraordinary rate. And this is something that's going to affect more and more of us as we all get older. I want people to know that, I want people to take away that there is a lot of momentum in the field of early identification and trying to treat Parkinson's disease, and that the whole research community is dedicated to trying to find cures for Parkinson's disease. A cure personally would mean that when I speak to patients in clinic, I can give them hope that there is something really meaningful we can do about their disease. Not just the patients that we're talking to, but the people that care about them, their friends and their relatives, and other people. So I'd like to be able to say, to instead of saying to people, well, you have Parkinson's disease and we have drugs that will help with the symptoms, I'd like to be able to say to people, you have Parkinson's disease and this is what we're going to do to help it go away again. So as Steve said, my name's Alistair Noyce. I work at the UCL Institute of Neurology and I'm a Parkinson's UK doctoral research fellow. I'm talking about early clues our bodies give for diagnosing Parkinson's, and I've broken the talk down into 3 parts. I'm going to start just by talking a bit about the background of Parkinson's disease and some of the major challenges that we're facing at the moment. Then I'm going to talk about biomarkers, what biomarkers are and how they can help us meet those challenges. And then finally, I'm going to talk about early identification of Parkinson's, which is something particularly close to my heart. I can tell you that when I arrived here at about 5 p.m. this evening, it was a lot less intimidating than it is right now. And I realised as everyone walked in this evening that we have quite a lot of representation from patients. Let's imagine that instead of the audience that we have here tonight, we just went out into the streets of London and invited an unselected group of 400 people into this talk. Limit it to people over the age of 60. And based on those 400 people, we'd probably have about 5 or 6 or 7 in the room that have a diagnosis of Parkinson's. Note I say diagnosis because there are far more people in the room that have small, subtle changes consistent with Parkinson's disease going on in their brain. These aren't people with diagnosis. So how can that be? Well,
As many of you will probably know, that we make the diagnosis of Parkinson's once we're about 50 to 60% of the way into the condition. And so the disease is taking place in people's brains for quite a long time, and they don't get a diagnosis until maybe 5 or 10 years after that starts. Now, that's not to say that all those people would have gone on to get Parkinson's. Maybe if they lived on and nothing else affected them, then a significant proportion would. But we've got no way of knowing who those people are. If we think about cardiovascular disease, we know that heart attacks and strokes, we can prevent them by identifying people with high blood pressure, diabetes, high cholesterol. And if we treat those things, then we reduce the number of heart attacks and strokes. Equally, prostate cancer, we have PSA measurement, colorectal cancer, fecal occult blood. There is no way of knowing who these people are at the moment. And this idea of living on and on is actually a reality. This graph here shows how life expectancy has increased over the last 50 years. And you can see that for males and females, we are achieving much greater seniority in years. And so living longer may unmask some of that hidden burden of Parkinson's disease. That's exactly what the figures show us. So here are deaths attributable to neurological diseases in 2005 and projections in 2015 and 2030. You can see that Parkinson's and Alzheimer's are rising at a rate of about 20% over those 25 years. Many of the other neurological conditions are falling, and cerebrovascular disease or stroke is increasing, but at nothing like the rate of Alzheimer's and Parkinson's. And that's because we intervene with aspirin, treatment of high blood pressure, cholesterol, etc. Let's go back to thinking about that diagnosis. The diagnosis that's made once the disease has been going on for quite a while. And we make this diagnosis based on observations, doctor's observations, and the same observations that James Parkinson made nearly 200 years ago when he watched and described 6 people in the Hoxton Square region of London. The symptoms of the disease that went on to bear his name, slowness, stiffness, and tremor, are the things that we know occur and make the diagnosis once we're 50% of the way in. Here's a gentleman that I see in the clinic who's very kindly let me use this video tonight to demonstrate what many doctors would call the classical features of Parkinson's disease, or the typical features of Parkinson's disease. He has a paucity of facial expression, he has a tremor, and he has slowness of movement that gets worse with repetitive finger tapping. He responds appropriately to standard Parkinson's medication. But the reason I show this is to say how inappropriate it is to talk about classical Parkinson's disease or typical Parkinson's. Because quite equally, I could have told you about individual B with Parkinson's, a young female, 35 years old, with inflammatory bowel disease, who a couple of years ago developed dragging of the left leg, later tremor in the left hand, and now, after being started on drugs, has very prominent psychological symptoms. She's volatile, she's reckless, she's impulsive and manipulative, and she feels that her drugs aren't doing enough for her, so she takes a lot of them. In fact, she tells her GP that she's lost her prescription so that she can hoard more drugs and take more. And this excessive medication is driving a lot of the psychological symptoms. Equally, I could have told you about patient C with Parkinson's, a 55-year-old man with very prominent anxiety and speech disturbance, who a little bit later on developed reduced facial expression. And he had a dramatic response to very low treatment, very low medication. But that response has waned with time, and now he has very little response at all to drugs. The truth is, I could have told you about any number of people with Parkinson's disease, and they all would have been different. And this reason, for greater than any other reason, is why we must strive towards getting personalised or bespoke treatment for Parkinson's. Of course, in reality, we're never likely to have such a wide portfolio of drugs that we can give a single drug to a single patient. But if we were better at defining subtypes of Parkinson's, then we could get somewhere near to that and maybe use certain drugs for certain subtypes. This huge oversimplification of various subtypes of Parkinson's, which doesn't take into account the psychological symptoms I just told you about or the non-motor features, hints at some of the types that there may be out there. We know there are genetic forms, and they're likely to behave and respond differently to sporadic forms. Equally, there are people that have very fast, aggressive disease and those that run a much more indolent, slow course. And from a motor point of view, we know there are people that are slow and stiff and people that tend to tremor more. And so looking at this, it's easy to see how people may not respond adequately to a kind of blunderbuss approach to drugs and how tailored treatment could be important. Going back to observational diagnosis, if you base the diagnosis on what you see in front of you, it's highly probable that you will make wrong diagnosis a proportion of the time. And in fact, we do misdiagnose Parkinson's about 10% of the time. And in this video, I'm just showing you some of the other diagnoses or disorders that present with features of Parkinson's. Some of these don't respond at all to Parkinson's medication, and some of them have their own very specific treatments. How do we measure disease? Well, we measure disease with these semi-quantitative scales where we rate stiffness, rigidity, and finger tapping speed and hand movement on a scale of 0 to 4, and we pull that score together to give a total score. And I put to you that here we're not really measuring disease at all, we're just measuring symptoms. And these symptoms, as many of the people in the room will tell you, change day by day, even hour by hour. They change according to what medication you had a few moments ago or a few hours ago, how well you slept last night, how anxious you are, or how much under pressure you are. So these are the real life problems. They're all applicable to clinical trial issues as well. And as it stands, we have drugs which treat the symptoms of Parkinson's disease, but no drug in a clinical trial setting that's ever been shown to modify or change the underlying disease process. That's because we're including people at too advanced a stage of disease. We need to put people into trials earlier. We've been putting diluted groups of people into these trials that have subtypes of Parkinson's, and also those with the wrong diagnosis. And also, we've not been making the right measurements. We're measuring symptoms and not the disease. I put ineffectual drugs here last because we have had a number of failures when it comes to drug trials for Parkinson's disease. But I would put to you that we don't really know these drugs are ineffectual if we've never truly got the first 3 points right. So the requirements are that we should identify Parkinson's earlier. We need to find people with disease before diagnosis. We need to make the correct diagnosis, ruling out other possibilities and identifying subtypes. And we need to find measures that are sensitive to the disease changing over time and treatment response, not just measures of symptom change. I'm going to come back right at the end to talk about early identification and first talk about correct diagnosis and measuring disease, which is where biomarkers fit into the talk. So biomarkers are anything that indicate an underlying biological process or disease state. What does that mean? Well, it means it's something we can measure that tells us that disease is, perhaps in a laboratory, that tells us that the disease is changing or progressing or that you're responding to treatment. And they may be laboratory biomarkers, or sometimes it's appropriate that they're clinical markers or imaging markers. And some examples, where can we look for biomarkers? Well, Parkinson's is a disease of the brain, so you can look on scans for various imaging markers of Parkinson's, but we know it's very much a multi-system disease. And so anywhere where your patients say that their Parkinson's is manifesting itself, you can look there as well. So here are some objective clinical markers that I'll talk to you more about, and then perhaps the more, when most people think of biomarkers, the regions that one would look in. So, for example, blood draws, saliva, spinal fluid, and potentially some tissue biopsies. In whom do we look? Well, we should look in patients with Parkinson's and compare them to people without Parkinson's. And if we find a marker, then it's very important that we look again and we try and replicate that, and that our competitors and our colleagues elsewhere also look in patients and compare to healthy people. Once we're confident about a biomarker, then we should look to see if it occurs in certain subtypes of Parkinson's, because it may not be applicable to all types of Parkinson's. And therefore, if you look at Parkinson's as a whole, you may be getting a diluted biomarker. And then we should look towards risk factor carriers, those people before diagnosis or in the very early stages of disease. And This makes the assumption that the markers that you find in people that have got a diagnosis of Parkinson's, i.e. moderate stage disease, will be exactly the same as the markers very early on in disease. So there are a number of studies around the UK that are looking at patients at various stages and also looking at clinical and classical laboratory biomarkers as well. The Tracking Parkinson study, which many of you will heard of, has recruited a couple of thousand patients immediately after diagnosis and is characterizing them from a motor point of view, a non-motor point of view, and a number of gene techniques and proteomic point of view. This will help define subtypes of Parkinson's disease and may define certain groups that would be appropriate for specific clinical trials, and tells us about the progression of Parkinson's very soon after diagnosis. The Icicle study had looked specifically at the early mental changes or early cognitive changes that are very subtle in early Parkinson's disease, and alongside doing that also looked at a range of clinical and laboratory and imaging markers as well. The OPDC study, which we will hear more about later from Michelle Hu, has recruited, I think, 1,700 PD patients, 300 healthy controls, and also some specific risk groups, people with a specific type of sleep disorder and also first-degree relatives. And they have a very strong biomarker platform that runs nicely in parallel with basic science studies of the underlying biology of the disease. And Richard Wade-Martins, I think, is in the audience. I think he spoke about this at the same event last year, so we look forward to hearing more about that in the next talk. Finally, Predict PD, which is the study that I'm involved in, we take a slightly different approach. Actually, we have very few patients with Parkinson's in our study, and we're concentrating very much on people without and trying to risk stratify them and taking a number of clinical markers, imaging markers, and biomarkers, exploring those in that group of people. I want to give you an example from Predict PD to illustrate a biomarker to you. I know at least one person in the room has helped us with this study. We're quite interested in non-invasive ways of measuring disease, and saliva represents a rational target for that. Patients often say that they have either dry mouth or excessive saliva. Sometimes they complain that they drool, particularly at night. Perhaps the saliva is very viscous or gelatinous, and sometimes it stains the clothes. And we know that two other groups in different parts of the world have found markers for Parkinson's in saliva. So a student that I was supervising last year, Joseph Masters, he took samples from individuals with Parkinson's in our clinic. He analysed them at the saliva lab at Guy's Hospital and compared them with the saliva from healthy volunteers. And what he found here was that the saliva of people with Parkinson's had elevated amounts of total salivary protein compared to people without Parkinson's. He found this using 3 different techniques, and then he went on and found that this specific protein, DJ1, was also elevated in PD patients, people with Parkinson's, compared to healthy individuals. And this is really interesting because this protein DJ1 is thought to have a role in Parkinson's and related disorders, and this was the same protein that those other groups I told you about had found as well, being elevated in people with Parkinson's. So this is evidence of replication, as I said, and it's very important. This suggests that saliva is a good place to look for biomarkers. And now we'd be interested to know if this elevation of DJ1, or indeed total salivary protein, is a feature of everyone with Parkinson's or specific subtypes. And what I'm particularly interested in is whether these changes are apparent in people before diagnosis. So biomarker research is moving on at an extremely fast rate, and it's very exciting. It will help. They will help us. Biomarkers will help us improve diagnosis, rule out wrong diagnosis, and also get a good measure of disease rather than symptoms. But now I want to go on and talk about early identification. And Predict PD is the project that I've been involved in for the last 6 years. As Steve Ford said, it was funded through an innovation grant in 2011, and after a year of that, it led into my Career Development Award from Parkinson's UK. Imagine being able to go to your GP, and they have a risk calculator which estimates your risk of Parkinson's disease, and if it's high, they give you a specific drug that reduces your risk of Parkinson's. That's exactly what happens for cardiovascular disease, and in fact, they sort people into high, middle, and low risk groups. And this is exactly what we wanted to do with PREDICT-PD. How do you find people at risk of Parkinson's? Well, first of all, we went back to the literature and spent a couple of years looking through everything that had ever been reported to take place prior to a diagnosis of Parkinson's. And we were particularly interested in things that could be assessed in a primary care setting. Now, what I'm about to show is called a forest plot. And what will appear is on the left here will be the factors of interest, the numbers of studies that those factors were shown in, and then over on this side we'll show you an estimate of the magnitude of risk each of those conveys. So, having a first-degree relative or a family history of Parkinson's seemed to increase your risk of Parkinson's by about threefold. And you'll see these diamonds as they appear. The further they are from the central line, the greater the risk they convey. Having constipation, onset in adulthood, or anxiety or depression seem to double your risk of Parkinson's, and having an exposure to pesticides or proxies for pesticide exposure, such as rural living or farming and agriculture, modestly increase risk of Parkinson's, whereas having had a head injury also increases your risk. So armed with that, and a number of other risk factors, and a whole load of protective factors, we put together a risk scoring process that we could combine with age and try and estimate people's risk of Parkinson's. Alongside that, we developed the brain test. Now, the brain test is a keyboard tapping test. This is a keyboard tapping test which measures speed and accuracy of movement, and it's done on a standard computer keyboard. People hit the S and semicolon key, like you're seeing, backwards and forwards as fast as they can. And what we did, first of all, was compare a whole load of people with Parkinson's to a whole load of people without, and showed that there were differences, and then also showed that the test could pick up differences between individuals with Parkinson's at different stages. And then we went and bought a whole load of smell tests. Now, these are scratch and sniff smell tests that I think should be on each of your rows and will be handed out now while I carry on talking. So this is called the University of Pennsylvania Smell Identification Test. As I say, it's a scratch and sniff test. There's 10 scents in each booklet, and you'll be passed one each to go along the lines. You scratch the panel, sniff, and try and answer which scent it is. Now, it's an American test, so you may not recognize all the odors. There's things like pumpkin pie and skunk on there, and root beer. But why are we worried about smell? Well, because we know that in people with existing Parkinson's, about 90% of them have lost their sense of smell when measured objectively like this. We also know that smell probably goes very early on, when those early changes are taking place in the brain, but before the movement symptoms come on. And so if you lose your sense of smell as an adult, that's nothing to be alarmed about. It doesn't mean you're going to get Parkinson's, but rather like having a family history, it does increase your risk, probably about 5-fold. So then let's go back to our general population with all different risks of Parkinson's disease. What we do is we invite them and recruit them through the PREDICT-PD web portal, which is at www.predictpd.com. And through that web portal, we ask them questions about all those early non-motor features and risk factors. And through that questionnaire and the answers that they give, we develop a risk score for them. We also get them to do the keyboard tapping test and the smell test, which is sent out to them. They scratch and sniff and fill in the answers online. And through that process, we get a high, a middle, and low-risk group. Now, as I say, we opened in April 2011, and we recruited about 1,300 eligible subjects. These are people, to be eligible, these are people without a diagnosis of Parkinson's or related disorder, aged between 60 and 80, male or female, living in the UK. And we've been following them up for the last 3 years. You see that at year 1 and year 2, we kept roughly 1,000 in, which is very good retention rates for an internet study. And we're currently running year 3, which opened a week ago today, and we've already had about 60% of our participants back to us. Are those smell tests making their way around? Yeah? So once we've risk stratified people, what are we interested in? Well, ultimately, we're interested in following up high and middle and low risk groups to see who develops Parkinson's or gets diagnosed with Parkinson's. We call it conversion, but it's diagnosis of Parkinson's. It's going from not having Parkinson's to having a clinical diagnosis. But on the way, we look at a whole load of other things, because this kind of study will take 5 or 10 years. First of all, we look at intermediate markers. Intermediate markers, this is our, we've defined intermediate markers as smell loss and problems with finger tapping. And so we look to show that there are differences in smell and finger tapping between high and low risk groups. And then I go and see people that are high risk and people that are low risk. It's very important to tell you that we don't tell anyone what their risk is, because we don't want to falsely alarm people or falsely reassure people. So for every high-risk person I go and see, I see an equal number of low-risk people. And with those people, we objectively measure movement using that scale I showed you earlier on, and we also measure thought processes and cognition, and we look for genetic differences between the groups and imaging differences. But ultimately, we're waiting to see who gets Parkinson's. The value of doing this is that this gives us an opportunity to define subgroups en route to a diagnosis of Parkinson's. It allows us to find who is it that loses their sense of smell en route, who is it that has disturbed sleep, who is it that has a specific gene. And actually that's quite exciting, because that means in the future potentially we can target treatment for those specific subgroups before they even get a diagnosis. I should tell you that we have a slightly biased sample. This was what's known as a pilot study or even a feasibility study. First of all, we wanted to see if we could recruit lots of people via the internet and if we could keep them in over a period of time. And the way we recruited people, we had a small media campaign, but we also had an email cascade through to members of Parkinson's UK. So actually, in our cohort, we have quite a large percentage of people that have about 20% of people have a first-degree relative, and about 30% of people have a spouse. Excuse me. But what this does give us is a cohort that recognizes the real value of what we're trying to do with early identification and early treatment and trying to slow or prevent Parkinson's disease. And these are some of the quotes from our participants. I want to thank the people that have supported the Predict PD project thus far, and some of them have supervised me through and some of them have assisted with all the various tests that we do. Most of all, I want to thank the participants and also the people listed at the bottom, not least Parkinson's UK, who have supported the idea since day one. In summary, I hope what I've shown you this evening is the potential value and importance of following early clues our bodies give us to achieve vital goals for Parkinson's. These are early identification, development of markers for disease, and subtype definition and characterization. These will pave the way for clinical trials of targeted treatment, which will mean that in the future, in my career, in my lifetime, this will offer a future that is in which the right drugs are given to the right patients at the right time. Thank you very much.